This lesson, we analyze the series parallel RC circuit. So let's go straight to the examples. Here we have a series parallel RC circuit. We need to determine the total impedance first, and then the total current. At the end, we need to find the phase angle for this circuit. Let's briefly look at this circuit first. The circuit has a source Vs that equals to 6 volt with 3 kHz frequency. And then it connects in series to a resistor R1 in series with capacitor C1. And then over here, this portion, this region, we have a parallel circuit. R2 and C2 connects in parallel. The whole thing, the whole region is connecting series with R1 and C1. We are ready to solve this question. Let's calculate capacitive reactance for C1 and C2, which are XC1 and XC2 respectively. We know XC1 equals to 1 over 2 pi f C1. That is 1 over 2 pi 3 kilohertz and 0.5 microfarad. Use calculator, I got 106.1 ohm. Use the same way, find XC2, that is 1 over 2 pi FC2 equals to 2 pi 3k hertz 0.033 microfarad. This equals to 1.61 kilo omega. These are the two important quantities. So first we can find the conductance G2, which is the conductance for resistor 2. That is 1 over R2. R2, it is for 80 ohm. Therefore, the conductance is 2.08 millisiemens. Next, we can find the capacitive susceptance for capacitor C2. So BC2 is 1 over XC2. That is the capacitive susceptance. It is 1 over 1.61 kilo ohm from here. And I use calculator, I got 0.621 millisiemens. We have conductance and also capacitive susceptance. We can find the admittance, this region. This is the admittance for the branch 2. This is square root G2 square plus BC2 square. Yeah, this is the G2 conductance for the resistor, and that is the BC2. the capacitive susceptance for capacitor 2. And then using these two quantities, we can find Y2. Substitute the variable with numbers. G2 is 2.08 millisiemens square plus BC2, that is 0.621 millisiemens square. I calculated it is 2.17 millisiemens. Once we find the admittance, we can find the impedance. So the impedance for that branch, second branch, it is the reciprocal of admittance. So it is 1 over 2.17 millisiemens. Use calculator, I got 460.83 omega. So now I got the impedance, but this is the impedance in this branch. We need to find the total resistance and also phase angle. Before finding the total impedance, let's find one more thing. The phase angle for that branch. We know the phase angle for that parallel portion of the circuit, let's call it phase angle theta p, equals to inverse tangent. And you remember for parallel circuit, to find the angle, we need to put the resistance on the top, numerator. So this is R2 over XC2. R2 equals to inverse tangent for 80 ohm divided by 1.61 kilo ohm, that is 16.6 degree. Now we need to find this, the series equivalent values for the parallel portion. Since we combine those capacitor and the resistor into a single quantity, and it is in series with resistor R1 and the capacitor C1, we need to find the resistive coordinate and also the capacitive coordinate. So don't forget this step. This is a very important but easily forgotten step. So Req, the resistance component, is the impedance of the parallel circuits. So Z2 cosine the X component theta P equals to the total impedance 460.83 ohm. This multiply cosine the angle 16.6 degree equals to 440.8 omega. So this is the resistive portion of the parallel circuit. To find the capacitive portion, let's call this is XC equivalent for the parallel part is Z2 and then sine theta P. This is 460.83 by times sine 16.6 degree. This equals to 131.4 omega. Now we are ready to find the total circuit resistance and the capacitive reactance. So for the total circuit resistance portion, R total, that equals to the resistor R1 plus the equivalent resistance portion from the parallel circuit. This equals to R1 is 2 kilo ohm. The resistive portion from the parallel circuit is 440.83 ohm. And at the end is 2440.83 ohm. The capacitive reactance, that is Xc1, plus the capacitive reactance portion from that parallel circuit, this is Xc Eq, equals to, since Xc1 is 106.1 omega, and the Xc equivalent is 131.4 omega. Adding them up is 237.5 omega. Now we are ready to find the total impedance. The total impedance Z total equals to, I hope you remember this formula, it is R square plus Xc square. In this case, it's the total resistance square. So this is R total. And let's still write this down. R total square plus Xc total square. This is square root. The number we calculated above is 2440.83 ohm square plus 237.5 omega square. Here I have to use calculator. Use calculator, I got 2452.36 omega. That is the total impedance of this circuit. And then let's do some cosmetic to make it look better. This equals to 2.45 kilo ohm. Whew, lots of steps. B, we need to find the current, and then C, we need to find the phase angle. Since we already find the total impedance, current is easy. Current equals to the total voltage divided by the total impedance. Since the voltage equals to 6 volt, impedance we just calculated is 2.45 kilo omega. So we got current equal to 2.45 milliampere. C is to find a phase angle. Theta equals to inverse tangent Xc total over R total. Yeah, since this is the phase angle of the overall circuit, we need to use the capacitive reactance total and the resistance total. This capacitive reactance XC is in the numerator, and the resistance total is in the denominator, equals to inverse tangent. Just plug in the numbers. 237.5 ohm divided by 2440.83 ohm. Punch this number into calculator, I got 5.56 degree.